Okay. So in case of enhancement, we are just going to have subjective criteria. So here what I have done, I'm just taking a different image, tile.diff. You can try with any image, and then I'm just taking the logarithmic transformation. The formula is C log 1 plus your input intensity. I'm just taking the intensity as I2. So I'm just finding what is the output for different values of C, like 1, 2, and 5, and I'm going to plot it. Okay, that is the first step I'm going to do. Afterwards, what I'm doing is I'm just taking the range as 0 to 1, 0 to 255, and 0 to 2 power 16. Where I'm making that changes, I'm just finding my C value as 1 by log 1 plus that range. Okay, thereby we are just compressing the data and we are finding how the result is coming, because as I told you, you're just applying combination of techniques. That's it. Okay, so let us run this and we'll see. It's a very simple technique. I'm directly, as I told you, I'm just starting with some simple techniques. Okay, so let us see figure 1 first. So the formula is C log 1 plus R, where R is your input gray level. If I put C as 1, this is my image, C2, C5. So I can easily see the details very clearly when I put C equal to 5. See the original image. I'm not able to get any details out of that. But if I increase the contrast, okay, by changing your logarithmic value, I'm just compressing or expanding the intensity value, you'll be able to get the details clearly. So whichever is good for you, you can take that result. Okay. So this is regarding varying your C value. Next, I have varied the range. If I take the range from 0 to 1, the image is this way. From 0 to 255, it's this way. And if it is 0 to 2 power 16, I'm getting totally washed out look. Okay. So if you want to increase the brightness level, you can just change the range in your logarithmic transformation as well. Okay. So this is regarding logarithmic transformation. As I told you, all these things will be coming under point operations, your thresholding operation, logarithmic transformation, and we are going to discuss about power law transformation and gamma transformation as well. So if you take gamma transformation, again, what is the equation? Now only I showed you, it's going to be C into R power gamma. So for different values of gamma, you'll be getting different images. I have just applied the same formulae. So I'm adjusting the image intensity and I'm varying the value for gamma. Okay, so here I have put gamma as 1, 3 and 0.4. So you're having a direct function called ImAdjust, which will adjust your gamma value. So if we run this, again for the same tire image, we are getting a good result if I put gamma as 0.4, and if you put gamma is equal to 3, the result is darker than the original. This I think sir would have shown you the image in Gonzalez. Actually for the original image, if you increase the value of gamma, the image will be darker than the original, and if you decrease the value of gamma, the image will be brighter than the original. So in this way, the gamma transformation will be giving you different contrast values. Okay. So this is regarding gamma transformation, and we are having a few more techniques like contrast stretching, bit plane slicing, as well as your gray level slicing. So what is gray level slicing? This like in between a particular gray level, you just increase the intensity value. Whatever intensity you want to highlight, you just take that gray level as maximum gray level, and the other gray level values you make it as 0. In that, if you don't want to change the background value, you just want to retain the background in the foreground, whatever value is within a particular intensity level, I want to make it as higher value. I want to highlight those range. In that way, I'll go for slicing with background. Okay, so that is the next technique. Please look through the code. I'm just taking Lena image here and getting the size of the image as m comma n, and I'm just taking two values a and b. That is, I'm just fixing two gray level value within that range. A, I'm taking round of L by 1.25. See, this you can fix it. Okay, it's your own formula. You can take any two intensity level between 0 and 255. I'm just taking two intensity value between my original range. I want to highlight those gray levels and I don't want to take the remaining gray level. So what I'm doing, I'm just putting two for loops. If my intensity value is greater than A and less than B, that is if my output is lying within those two levels, I'm making that value as 255. Otherwise, I'm just retaining the same value. Here, like those who studied image processing would have known, in case of gray level slicing, you can retain the background value or you can just make it as 0. If you want to make it as 0, here you would have given 0. But since I want to retain the background value, I'm just taking it as the same value. Okay, if it is not within this range. So this is actually gray level slicing with background. All these are some simple enhancement techniques. So this is how the image is looking before gray level slicing and after gray level slicing. So this is regarding some simple transformations, whatever sir has discussed in the last class. I just want to